So we just looked at the variance, which we said was just equal to our standard deviation squared. And one last one is the mean absolute difference. Now the mean absolute difference is very, very similar to the calculation of the standard deviation, but instead of squaring the distances, we take the absolute values. So we simply look at, hey, if it's a negative number, let's make it positive. If it's a positive difference, we're going to leave it positive. That makes it so that we don't have to take the square root at the end. So if we use our sigma notation, for our sample data, we're going to divide by n minus 1. We're going to take the sum of our values, subtracted minus the mean, and we're going to add all these up. Again, since we're not squaring the values, we're just taking the absolute value, making these values all positive. We don't have to take the square root at the end. And similarly, if we have a population, we would divide by n instead of dividing by n minus 1, where capital N stands for our population size, lowercase n stands for our sample size. And everything else over here is the same, but this time we're subtracting the population mean. And that is our formula for the mean absolute difference. It's very similar to the standard deviation. It's not very often used. I just wanted to kind of introduce it quickly. We don't really spend any time looking at mean absolute difference, but again, to show you there's many different measures of variation, just like there were many measures of center over here. So the important question is, which measure of center should I use, right? For what kind of data? So the IQR is the most appropriate measure for skewed distributions. So over here is what we want to use for skewed distribution or distributions with outliers. This is because they ignore those outliers, and we call it a resistant measure of variation over here. The standard deviation, on the other hand, is the most appropriate measure of measure of spread for symmetric distribution, and it is not a resistant measure to outliers over here. So we can see how the IQR goes with the median, the standard deviation goes with the mean, and for the measure of center, we use the median for skewed distribution, and we used the mean for symmetric distributions. So we can kind of put together a little table over here, and you'll see this, many times throughout the course as we're reviewing. So let's say we have a symmetric distribution over here. We have a skewed distribution. We're going to look at the measure of center, the measure of spread or variation over here. For the symmetric ones, we wanted to use the mean. For the skewed, we use the median. For our variation or spread, we use the standard deviation for symmetric, and we use the IQR for the skewed distribution. Here's some properties for all measures of spread. Measures of spread are all greater than or equal to 0, right? So the lowest we can get would be 0. If there is variation with our data, it's going to be greater than 0. Values that are very close together have a small measure of spread. Values that are very far apart have a large measure of spread. All right, below that we have our calculator commands, and this shows both the TI-8384 as well as the TI-36X. I will post 2 tutorials how to use either one of these calculators. Keep in mind that right now we're in an online setting, so that you can also use online calculators to calculate these values. One thing to note real quick as well is the notation in the TI-8384 and the 36X Pro. It indicates the sample standard deviation with an S of X and the population standard deviation with a sigma of X. So you always have to look for which one is the correct value. Are you looking for sample data? in which case you're going to look for the S of X, or are you looking for population data, in which case it would be the sigma of X. Most of the examples we look at are looking at sample data. Now, other calculators use different notation.